Alright, today we're going to do 8.8 improper integrals. This is some limit stuff that we did back in chapter 7. So recall that the integral from a to b of f of x d of x is an is a definite integral. An improper integral have either one, limits of integration that let either a or b equal plus or minus infinity. In this case, we use limits to find the value of those improper integrals. Or two, they're discontinuous within the integral ab when ab is this I used as all real numbers. I couldn't find the notation. Sorry. I don't think that's what it means mathematically, but I was looking for that one. So if you want to cross it off, that's fine. Okay, so let's do example 1. And then it says, determine whether the improper integral converges or diverges and evaluate if it converges. So we're going to do the integral regardless. So if it converges, then we just have like the answer is a number. So we just have like a number, any number. If it diverges, oops, I put an S. If it diverges, then it goes to infinity. Okay, so let's do the problem. So since we can't have the integral to infinity, right? 1 to infinity, then I'm gonna do the limit as b approaches infinity, and I'm gonna make that integral 1 to b. Okay, and I'm still writing this exactly the same way, dx. So let's rewrite this is just a notation, so we don't we remember what we're doing. Oops. So let me rewrite the integral 1 to b, and I'm going to do this as 3x to the negative 5 dx. Okay, so then this will be the limit as b approaches infinity of 3 over, and this will become negative 4, x to the negative 4 evaluated from 1 to b. Let's rewrite it correctly with no negative exponents. So I have 3 over 4x to the 4th evaluated from 1 to b. So let's evaluate it. So I get negative 3 over 4 b to the 4th minus negative 3 over 4 times 1 to the 4th. I forgot my limit. Hold on. Okay. So what I have here is a double negative becomes positive. As b is approaching infinity on this graph, we're heading to 0. So that whole thing is going to be 0 plus, and then this is just 3 over 4, which is just a number. So we have 3 over 4 as the answer. So then this converges. Okay, b, again, 4 to infinity, the integral, and then 1 over x ln of x cubed dx. So again, I'm going to write the limit as b approaches infinity from 4 to b, and 1 over x ln of x cubed dx. So I'm going to use u substitution here. So u will become natural log of x. So that means that du will become 1 over x dx, which is perfect because this is here So then I get the limit as b approaches infinity from 0 to b. Not 0, sorry, 4 to b. So this really just becomes 1 over u cubed du once I do the substitution. So then I take the integral. Oh, let me rewrite it. Limit as b approaches infinity of 4 to b and u to the negative 3 du. So this becomes, so once I take the integral, this becomes negative 1/2 u to the negative 2, and then evaluate it from 4 to b. Of course, we're not evaluating it for b, so we have to substitute our ln of x, okay? So this needs to go back here. So the limit as b approaches infinity of negative 1/2, and then I'll just put it down here, ln of x quantity squared, and then evaluate it from 40. Okay, so then let's plug it in. So this gives me the limit as b approaches infinity of negative 1 over 2 natural log of b squared minus a negative 1 over 2 ln of 4 squared. Okay, so again, this becomes positive. And again, this part, the limit part, so if we have the graph of ln of x, then as it's going to infinity, then this is getting closer to 0. And then plus 1/2 natural log of 4 quantity squared. And then so we have 1 over 2 ln 4 quantity squared. That's our final answer. And this also converges. Okay. See? Now here I don't have an infinity, but if you realize if I plug in 0, it will give me undefined. So that's going to be what I'm going to rewrite. So the limit approaches 0 is from b to 5. And then this is, and I'm just going to already rewrite it 10. Actually, I'm going to leave it because that one doesn't have an exponent. So 10 over x dx. So let's do the integral. So the limit as b approaches 0 of 10 natural log of the absolute value of x, b to 5. Now, if you don't put the absolute value here, we're looking at positive numbers that we're going to integrate. So it's up to you if you put it, you don't put it. I won't knock points off for that here. Okay, so then we have the limit as b approaches 0 of 10 ln of 5 minus 10 ln of b. Okay, so the part that I'm looking at as a limit is that here it's just 10 ln of 5 minus, well, if we look at the graph, right, if I graph it real quick, graph kind of goes something like that. So we're looking as x approaches 0, right? So then let me get a different color. So then it's coming here. So then it's actually going towards, y is going towards negative infinity. So then my answer here is going to be infinity, which means it diverges. And then the last one we're going to do again, we have infinity. So the limit as b approaches infinity. So we have the integral from 1 to b, 3 over x dx. Okay, and then let's take the limit. So the integral. We have 3 ln of, again, absolute value of x, unnecessary, up to you if you have it or not, evaluated from 1 to b. Okay, so then I get the limit as b approaches infinity of 3 times the natural log of b minus 3 times the natural log of 1. Okay, well, again, the same graph, right? As it's going to infinity, then y is going to infinity, and then this just gives me 0. So this is just infinity. So again, diverges. Okay, that's it for 8.8, and this will end chapter 8.